So hello, I would like to we would like to present European Advanced Networking Testing Center SRv6 demo focusing on Flex Algo with delay metrics. I am Krzysztof Szarkowicz, I am the Principal Technical Marketing Engineer from Juniper Networks, and I would like to ask my colleagues as well to introduce themselves.
I'm Giles from Calnex.
Jakub Horn, Technical Marketing Engineer, Cisco.
Diego from Nokia.
Hello everyone, this is Prabhu from Spirent Communication.
So let me start with a small description of the technology aspects that we are covering in the demo. So first of all, we are covering segment routing over IPv6, SRv6 network programming. It is different kind of services we can transport over SRv6. We will focus in this demo on one kind of service, layer 3 VPN with v4 IP addresses over SRv6. The second aspect is IGP, traffic engineering, metric extensions. So again, there could be multiple metric extensions to distribute different kind of information required for the TE, for traffic engineering, for the links. In this particular demo, we are focusing on the delay delay metrics to be distributed across these extensions. And then the next technological aspect that we are looking here is IGP, flexible algorithms. It's called as well IGP Flex Algo. So basically with IGP Flex Algo, we'll be able to create some sub-topologies in the network or specify some different metrics used by the SPF calculations. And with this, we can create some restrictions or constraints in the path calculation for the traffic. And the next one we are looking for is two-way active measurement protocol live, so TWAMP live. So this is light version of the TWAMP to do the automatic dynamic measurement of the delays. Here particularly we are looking for the link delay measurements, and as I mentioned previously, we're distributing these results of these link delay measurements as the link delay metrics. And last but not least is SRv6 BGP based overlay services. So it defines procedures and messaging for SRv6 based BGP services, including layer 3 VPN, EVPN, internet services, and some other services to come in the future eventually. As mentioned previously, we are looking here for layer 3 VPN. And particularly the test purpose is to provide, to verify interoperability for this couple of aspects of the technology. So we will verify the interoperability for layer 3 VPN over SRv6. So this is so-called EANTC seed, segment ID. Then the second, we verify ISIST metric extension, here delay metrics. So we verify that we can exchange this delay metric between different vendors, and we understand each other, and we can react based on these metrics. So we receive these metrics and we'll be making path calculation based on that. So, and then last but not least, we are looking for verifying interoperability for ISIS Flex Algo extensions, specifically here in SRv6 deployments, yes, because we could have as well a Flex Algo for MPLS. We are looking for SRv6. So here, Flex Algo specific SRv6 locators, how we distribute these locators, do we understand each other? Flex Algo with link delay metrics, then traffic mapping to Flex Algo SRv6 path, and traffic rerouting based on changes in the links metrics. So link delays will change, and based on that, we will reroute the traffic. So our topology, demo topology looks like that. So we have 4 physical routers, so to say, plus Spirent emulating the PE device. So we have a Cisco device in the topology, we have Huawei device router in the topology, we have Nokia device in the topology, we have Juniper router in the topology, and as well we have Spirent to emulate PE as well. So it's part of the SRv6 topology Flex Algo. And then we are sending basically full mesh of the traffic between these devices, and based on the of course the current delays that we have in the network, this traffic is flowing over the shortest delay path. In the topology, we have as well in 2 places we have Calnex device. This Calnex device is used to introduce the delay, so we can change reprogram this Calnex device to increase delay, decrease delay. At the moment on this link, the Calnex device introduces 5,000 microseconds, so 5 milliseconds in one direction. So it's 2 milliseconds round trip on this link. On this link, Calnex device doesn't introduce any specific delay. So this is more or less what we measure at the moment in the network. as you show, the red numbers are statically configured. So we measure basically dynamically the delay on these two links with Calnex device. And now we show a little bit in the configuration in the routers how this looks like. We might start, for example, with the Cisco.
So here you can see the partial output of the ISIS database, where each link in the topology is advertising particle metric. So for example, here you can see the 5 milliseconds metric between Nokia and Juniper measured bidirectional, right? All the other metrics are down. So right now we will decrease the metric on this particular link. Okay, Jules, can you decrease the latency on the link between 1 and 2?
Sure. Doing that now. Okay, that's done.
Okay, so here after the change, we can check the latency of both links is still dynamically measured, and it's easily and quickly propagated into the IGP. So here is the from Juniper to Nokia, and here is from Nokia to Juniper.
So as we showed before, we decreased the latency on this link. This was automatically measured, so we didn't make any configuration changes. The only change was happened is here on this Calnex device. The delay was decreased. That was automatically measured and propagated as shown by Jakob. Now let's go to the next step. So in the next step, we will basically look at the traffic flows after this metric was decreased, and we will see some flows going over these links, and so on. I will show now here from the Juniper perspective how these flows are distributed. So we see some flows going here, and we see some flows going here. Okay, just a quick way to check how the flows are distributed. So let me share my screen now.
Let me show the statistics here on the interfaces. So basically, this is the statistics on the interfaces that we are seeing. So we are seeing some incoming interfaces and outgoing interfaces. Some flows were not shown in the picture because we have some flows to Spirent device as well. So that's the reason we don't see these flows. But you see the direct interface to Nokia is 105. Over this direct interface to Nokia, we see one flow is going, so one flow is 1000 PPS. So this is what we can observe in this picture.
In the next step, we'll again change some structure here on the delays. So we'll change the delays on the link between the Cisco and Nokia. And as well, we present that this time maybe from Nokia side, because Cisco already presented. We'd like to ask our Calnex colleague to increase the delay on the link between on the second link, yes, that we are using in this topology, which is between Cisco and Nokia.
Okay, I'll do that now.
Yeah.
Okay, that's added 5 milliseconds.
In this section of the demo, we will show how traffic is being routed from Nokia to the rest of the devices, in this case, Juniper and Cisco, based on the shortest path based on link latency. Okay, so first of all, I wanted to show you that we are measuring latency towards both Cisco device and Juniper device. So here we can see that this is the last delay reported. Towards the Cisco device, you see the latency is around 5,000 microseconds. And to the Juniper device, you can see now that latest latency reported is around 72 microseconds. Okay, so now we can also see, for example, in the Flex Algo topology for this specific test case, that a Cisco device, for example, is reachable via Juniper device with this latency in microseconds. In this case, around 200 microseconds, right? So, and also Juniper device, of course, is reachable over the directly connected interface, okay? Via, or in this case, with a latency of 72 microseconds. And a bit more evidence on that is that, in fact, in the channel table that we use to solve the next scope of the services, we can see in this case that, of course, the prefix or the prefix locator associated to the Cisco device is reachable via the Juniper interface, as we have seen before. And also, of course, the Juniper locator is reachable over the interface directly connected to the Juniper node. Okay, so here I will show you the ports, the physical ports connecting those two devices. So, for example, port 11C15 is connecting to the Juniper device, and port, I think it was 11C11 is connecting to the Cisco device, right? And now with these last commands, we can see, in fact, that traffic is flowing, you see, via the Juniper node, and it's not flowing via the Cisco node.
So as you see in this demo, we have presented SRv6, FreeVPN of SRv6, and we concentrated on Flex Algo with delay metrics. We have manipulated certain delay metrics, and you see the traffic has been rerouted based on the automatic measurements using pump-light, and distribution is the result of the automatic measurements in ISL extensions delay metric. So thank you very much for your attention. Thank you.